Hello guys, this is Sathvik Hegde from Coding Club. So today we are going to discuss about the first two contests of yesterday's biweekly contest. So the first question is minimum operations to make array values equal to k. So basically we are given an integer vector, we are given an integer vector and a value k. So they have defined h as a valid if that in that array all the elements greater than h are identical. So basically, let's take 1, 2, 3, 4, 4 as some array. So if h is equals to 3, then all the values which are above h should be identical. So h is equals to 3 is value. So now what we should do is you are allowed to perform the following operations on nums. Select an integer h that is valid for the current value for each index I, where nums of I greater than h, set nums of I equals to h. So what we need to do is we need to select an index whichever greater than that should make equal to k. So we are given k. So after thinking about this, we get to know that if let's say there is one element in the vector which is smaller than k, then we cannot make this. Why? Because it is called valid if all the values above array, above the k value is only possible. So let's start implementing. So what we are going to do is we'll traverse in the array. If nums of I less than k, return -1. Fine. So we will traverse in the array. If there is one value in the vector which is less than k, then we should just return -1. Then after this, for this, what we have to return. So we need to make every value greater than k as equals to k, right? So, but here we are performing like not 3 operations on 5 but 1. So the best way to remove uh, all the duplicates is to use a set. So we'll use set in this. So if else, if nums of I greater than k, so if there was a greater element, then just insert inside the set. Now the set would have removed all the duplicates and made it as a single number. Now just we need to return s.set. So let's see, it works. So yeah, it works. Let's just submit. So yeah, it works. Now moving on to the second question. So yeah, the second question is minimum time to break locks. So yeah, there is a guy called Bob. He's stuck in a dungeon and he must break n locks. He's requiring some energy to break. So basically there are n locks, which is the array size of the array, and he need to break all the n locks to get out of it. Now the required energy for each lock is called strength. So to break this lock, which is the first lock, we need 3 amounts of strength. To break second, 4 amounts of strength. Fine. Like that, we need to break all the locks. Okay. Now he has a sword. The initial energy of the sword is 0. The initial factor x by which the sword increases is 1. So basically at 0th second, his sword has strength 0. At every second initially it increases by the factor increases by 1. Right? Then once he breaks a lock, to break the 8th lock, as I said, to break this lock we need this much of strength. So after breaking a lock, the energy of the sword resets to 0. So after breaking every lock, so let's say it became some y value, the strength becomes y, and now you can break a lock. Take lock. Now after breaking, it resets to 0. Fine. So after breaking, it resets to 0. And one more point is the factor x increases by a given value. So now every second it increases by a factor. Fine. Every second it increases by a factor. And after breaking a log, the factor increases by value k. Fine. So now how to do this? See, one thing if you notice is the constraints is n. For a long time you can think doing this greedily. Like you can first approach what you can think of is you can sort and then go from starting, which is the best. When it gets over, then you will just break it, then return the time. But the thing is, if you see the first test case here, see 341 is the test case, right? 341 is the test case. So k is given as 1. K is equals to 1. Now initially at 0th second, strength is 0. Strength is equals to 0. Now after 1 second, strength becomes 1. After 1 is equals to 1. Now it becomes 1. Fine. The strength becomes 1. Then after strength becomes 1, you can break third law. Break third law. Fine. After breaking the third law, the strength again resets to 0. Then the factor at which the strength increases every second now increments to again by k, increments by k. So now after breaking this one, so the strength would have been increased by k. So now at every second it will become 1 plus 2, that is 3. Fine. Now the factor would have become 3. Now at every second it increases by 3. Fine. If you see here, oh wait 1 second. So after breaking the third law, it would increase by 2. My bad, sir. It will increase by 2. Fine. Now 2, when the strength becomes 2 after the second, see, like after the first second you break the third law, which has strength of I equals to 1. Then it increases by k. So now the factor would be increased by, would have become 2. Then afterwards, again for the third second, again it increments by 2. So now it will become 4. So right now you can break either first lock or second lock, but it's always optimal to break the second lock. So you break second lock, which has value 4. Now you can break the first lock also, but after breaking the first lock, the again strength resets to 0, and you need 2 more seconds for to go to 4. So which will be total 5 seconds. But if you break the second lock, which has value 4, then what happens is for the next time the x factor would have become 3, and you can after 1 second itself you can break first law, so which will make the optimal as 4 seconds. So now how to implement this? See, as n equals to 8 we observed, one thing we can think of is we generate all the possible permutations of the vector and then check which is the best time. So let's start. So initially let's take answer equals to 0. Fine. So this is the final answer which we are going to return. We'll make small k. Fine. Now to generate all the possible permutations, we need to sort it first. Fine. So after sorting it, we'll use a do while loop. Do the operation of counting while next permutation of v dot begin comma v dot end. Fine. So what we have to do for every permutation, we need to calculate the time it takes. Fine. So now what we should do for every permutation, we will take int, let's say current is equals to 0, and then we will take one more thing is int x is equals to x is initially 1. Fine. Now what we need to do, we need to go through the loop plus plus. So we know we need to go through the loop. Then what we need is uh, cur plus is equals to c log float of v of I by x. Fine. And after you break every log, x plus is equals to a. Fine. So now, like initially, what cur is 0. So the strength is 0, right? I mean, to break the log. Then after breaking, let's say first block, it would be inserted, right? So it requires first second. Then 3 divided by the x factor would be increased by k. Now it would have become this thing. It would have become 2. So we do 3 by 2. C love 3 by 2. Why? Because initial every second by 2 it's increasing. But you need to break 3. You need 2 seconds increment, right? So that's why you need to use C. And why float here? Because if seal won't work unless like if you don't use float, then v of I by x would have been already converted to integer and the seal function wouldn't. So now your answer is equals to min of answer comma cur. Answer we need to keep it as int max. Right. So we are checking for every permutation possible whether the time taken for that permutation which is the min. So here return answer. Let's see if it works. Yeah, it's working. So let's just submit. Yeah, got accepted. So yeah, these were the first two questions of the contest. I hope you guys understood it. Thank you.
Coding Club.